Another cool shader. Always making them so cool. Okay. That one. Okay. Working hard. Got my cool hoodie on. Well, warm actually. Are you? Hmm. Yo. Uh. Right. Okay. So immediately, what I'm thinking. Whoa, whoa, whoa! What is that? Uh. Is the minimum calculation? Is there multiple? Evidently not. Mindest 2. Yeah, okay. Wait, couldn't you balance this without this? V dot V. Like, don't. Like, this is VV right here. Couldn't you just add one V here and one U here? And then the V and U count are different? Or the same, rather. That would be considerably smaller. So look at this. Let's count U's and V's. UU, there's 2 in the top. UU, there's 2 in the bottom. VV, there's 2 in the top. VV, there's 2 in the bottom. So only the P's are left. I think that does it. I don't know why it wasn't like that. Where? Oh, it was divide. Oh. But also, okay, to get it just the P. Okay, it's because that was there over the whole thing, and it wasn't cross multiplying. Okay, I understand. Okay, this is actually less work here. GG. Yeah. Okay. Subscribe to Tier 1. Mr. Paint Shooter, thank you for subscribing. Supporting the homeless. Not exactly true. I am a homeowner. But thank you. Okay, so this is just crazy. So we can go like, instead of doing Mindist, we can actually just like do the calculation. What if I slap it into AI? What do you think will happen? It'll probably just spit out something wrong. So I'll just do it while it's going. But like, gotta run the AI, right? Make it feel useful. Oh. Firefox? Hello? All right. I'm going to restart Firefox. Okay. Where did it go? Oh. It just said get. Bro. Where are you opening this page? I cannot locate the Firefox tab. Cheers from Argentina. Is this just like busted? Yeah, it's just busted. Yeah, okay. Yeah, your browser encountered an error. Bro. Really? Look, the mouse changes. It's like, oh yeah, enter text. Oh yeah. Okay, well now it's here. I have a hard time believing that it's going to keep working. I've never been to Argentina. In South America. Okay, so what I want is for this code, refactor this code to cross multiply within an if else style minimum calculation to reduce the number of multiplies. Paste. Blown away with machine learning. Build my own transformers from scratch. Do you mean built? That sounds cool. I haven't really dabbled in AI. This is like running locally. So like if we look at my GPUs, they're going, they're going. But it's just a command from something. Yeah, this looks not good because you don't actually need to do these calculations. Switch. This isn't C++, man. All right, I'll just do it myself. All right, so UVP, but with the UV component balanced out. Okay. Wait. That's right, VW. Okay. Wait, VW. No, that's okay. Woo, 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 woo. That's my impression of a dog. Okay. So like this, let brr equals brr, semicolon. You speak Spanish, not Portuguese. I have been to Spain and Portugal. Yar. Equation as a proxy for a theory for neural networks. That's a long chain of this for that. Created an equation as a proxy for a theory for neural networks from a paper. Released a few months ago. A lot of qualification. I don't do a lot of like reading papers and implementing algorithms from papers. What I'm doing right now kind of counts, except it's not a paper. It's just something my friend wrote. So this is if VW is the minimum distance. So that would mean that it's less than both of these. This less than that, and this less than that. So you guy and you guy. But also we need to balance out the components. So VW, we need to balance that out on the right hand side here. Balance. Then UV, we need to balance that out on the left hand side. UV. So that we remain doing integer calculations. Okay, once again, VW is right here. Balance it out on the right hand side. Cross multiply. WU, balance it on the left hand side. Actually, okay, it's a positive number. It cannot be negative and change the equality. Yay! Okay. There's only 3 cases here. I guess I should do this. What is the algorithm for? This is essentially just to find the closest point on a mesh to a point, but it's abstracted over, well, no, not yet, I guess, but it's my plan is to abstract it over mesh queries. So you could have different kinds of meshes. You could have, I'll just show you the mesh query. So mesh query, just ignore that. Mesh query, go to definition. Okay, so this is like a trait. It's a thing that you can ask where a vertex is, and it'll give you the vertex coordinates. It'll ask, you can ask about topology, like which edges does this face have? Which faces are beside this edge? Which vertices are at the ends of this edge, etc. So this is like querying mesh topology. It has many dimensions. It's a simple 3-dimensional mesh. This is for a game I'm making. I can show you that too. Strafe. Yeah. Surely it works. Oh. It doesn't like performance for some reason. Oh, you know what it probably is. I bet you it's the AI hogging all the RAM. Yeah, that was it. So yeah, this is the code. It's a standalone game engine-ish. The game is the engine, and it's written in Rust. And I've been working on it for about 2 years. So I already have several algorithms in this, and yeah, so it's this one is very interesting. So when I teleport to the start, I need to, when you teleport anywhere, you need to determine which objects you're in contact with because you teleported somewhere, right? So, well, how do you do that? Lots of different ways. But my plan is to use this algorithm that finds the closest point on a surface of a mesh to a given point. But I can also use that for two meshes. So like if you imagine you have two meshes and you're trying to find like the closest point between the two meshes, you can actually use this same algorithm and use a Minkowski sum of the meshes and do the relative position between them, and it's like the Minkowski sum is like strapping one mesh to the other at a fixed angle, and then if you imagine the center point of the mesh tracing out a new surface everywhere on the other mesh, that surface is the Minkowski sum of the two meshes. And just by finding the closest point to that sum mesh is the same as finding the closest point between the two meshes. And I'm also using the Minkowski sum for collisions. So like you can imagine it would be useful to know when two meshes collide. But once again, I can have this like Minkowski sum and then just trace a point onto the Minkowski sum mesh. And it's as if I traced the meshes together as well. So it's a neat abstraction where I can have these simple algorithms and then use the Minkowski sum abstraction. Actually, I can just go show it. It's at the bottom of this. Minkowski with a W. Can you write that? Oh, you know what? I should increase the scale. There, that should be easier to read. Minkowski. I'm pretty sure that's how you pronounce it. Yes, so you can see that I implement mesh query for Minkowski mesh, and it's made up of two sub meshes. But you can query it like it's one mesh, and that's sort of the trick here. Properties for my transformer. Are you using meshes with AI? Earlier shadowed variable. Huh? Oh. I see. I guess I'll say. How do you len, whatever. Okay. Okay. Yes. Okay, so this is if VW is the minimum distance. Using ideas to optimize. I find it really cool that the neural network inference libraries can find an optimal place to split the neural network and run it on two graphics cards, and then like communicate the signals across the boundary between the two GPUs. And so you don't need one GPU with all the VRAM. It's very useful for me, who has 2 GPUs. I can't think of how Minkowski sum could be useful for neural nets. It's very much a mesh game developer tool. PyTorch tricks. What's this llama.cpp? So C++ tricks. All right, so so if one of these is not true, how many? You need to do 3, right? With 4 branches. Yeah. Versus, oh my god. Oof, excuse me. Yeah. Okay. So I think I want the else case to be this, because that's the simplest to write. Okay, so this is if VW is less than UV, then if VW is also less than WU, then that means that we're in this case here. Okay, so now in the else case here, we know that are they doing the same thing? Yeah, UV versus. So what does this say? Ugh. My brain. LT info. I don't know what any of that means. NVIDIA owned the machine learning. Yes, indeed. There is a Vulkan backend for Llama CPP. ROCm kind of just sucks. It sucks to set up. It sucks to use. Like Vulkan is pretty much already better. ROCm in Linux. Is there a package? ROCm. ROCm Soxum. LLVM. Why is there like 100 packages? ML libraries. Where's the one that's okay? That's got to be it. Well, at least there's a package. Direct ML. Oh no. Classic Microsoft naming. VW is less than Woo. Okay, I need to like do it in my head with ABC. ABC. If A is less than B and A is less than C, then we know A is smallest. Else, if A is not less than C, that doesn't tell us anything about B and C. God, why can't I think of this? So A is less than B. Should I be doing B is less than C? Because then you have a sort of like triple. It's sort of in a row. And then, yeah, because then you know that B is the greatest. Because you know nothing between B and C with this. So what's the opposite of this? Okay, if C is greater than or equal to, or if A is greater than or equal to C, does that tell us anything? A is less than B, but it's greater than C. So that puts C at the bottom. So that does tell us that C is smallest. If A less than C, otherwise C is smallest. That does tell us. Okay, else B is less than A if basically we're gonna need B less than C, right? Why don't we go C less than B, oi, because then it's just obvious. So if B is less than A, it's actually less than or equal to. If B is less than A and C is less than B, then C is the smallest. Fantastic. So we've actually got two C cases. Else, this must be B smallest, but let me see. So this would mean that B is less than or equal to C. So B is less than C and B is less than A. So this is B smallest. B yourself. Okay. So we can actually flip this condition and end up with C in the else case, which I think is cooler. So B less than C. Okay, so this is my thinger. Okay, so C smallest, I do believe. So this is VW woo. VW woo. Is this okay, what's going on here? Woo. Woo. Who is woo? Okay, so we want A, B, C. We want C to be uvuvuve. Because it doesn't appear here. This is VW, this is woo. So we want C to be this. So we go like A equals VW, B equals woo, C equals UV. Okay, so first A less than B. VW woo 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 woo. So we want this here instead. This is our first comparison. Okay, and then A less than C, VW UV. Zoink, like that. And then now C goes in here. Oh Okay. So then now we have an else case. And another else case. Okay, and that is B less than C. So woo UV. Woo UV. Oh. Okay, so this should be correct. I do believe. Okay. Brain power. Valve is developing everything on Unix. Well, no, it's Linux. Unix actually doesn't really exist anymore. No one uses it. Linux is Unix-like, but it is not Unix itself. There's a lot of lore and history. Push AMD for good. Valve is not really doing AI stuff though, so they're mostly doing games. All right, this is excellent. This will have a lot less bit width. I actually have an interesting math library that I wrote, where the numbers are all integers, and when you multiply, they widen into wider numbers. So if this is 64 bits to begin with, and this is 64 bits, the result of the multiplication will be 128 bits. So you always get an exact calculation, and you never overflow. I'm for the game here. It actually does not use any floating point calculations. Well, that's actually not true. It does use them for the graphics. I might change that though. I might make the graphics also use integers for funsies as well. Oh. Would that be... That would be kind of hard though, because I don't have a cool library. Sick hopping. I would hope I'm good at bhop. The game is bhop, and I've been playing for 10 years. I would hope I'm good at the game. Ugh. Damn. Bug. That's basically what I'm trying to fix by adding this algorithm. Is there's many ways to fall through the ground. I'm just gonna fly up here. And I'm hoping to fix at least one of them by having this new algorithm. Actually, the algorithm I'm porting is from another game that I made. Which is on Roblox. But the algorithm was written by my friend. FPS good. This one has sound. And is like an actual game that people play. So like server list. You can see there's like actually people playing it, and there's a surf as well. There's people playing that. This is my game. Is this stream lagging? Probably is. Can't do it. Can't beat my time. Heaton Sun. Who's Heaton? Not everyone knows about B-Hop. That's fun that you do. Oh. Ooh, Doob. Let's see this run. What? You can jump that? Aw! Wow. You play CS and you don't know who Heaton is. I actually don't play CS. I started B-hopping on Gary's mod. Is there any maps that I haven't beaten yet? No. Oh, that one's really fun. I want to do a run. Oh, no. What? This guy just got pending right in front of me. On the leaderboards, there's like approved times, and then there's blacklisted users who are hidden from the leaderboards but can still play the game. The concept of B-Hop is before CS. Yes, Quake. Exactly. There's a whole moderation system. Is it going to actually transfer the server for me? Oh, no, it's a private server. Oh. Ah, okay. I can't go there. Whatever. Okay. Time for work. Okay. Reduce min dist bit width. Calculation width. Bit width. Very excellent. Good job. Okay. Any other stuff? Yeah, I think that this cross multiply is a good way. So if we count the number of V's and U's in here, the point is to get the V or the P, the amount of P in a certain direction. It's like a linear projection. So when you compare the two numbers, the V's and U's lengths, vector lengths, should balance out. So the number of V's should balance the number of U's. So we can count them 1, 2, 3 in the top, 1, 2, 3 in the bottom. And then U's 1, 2, 3 in the top, 1, 2, 3 in the bottom. But I can actually reduce the amount of calculations going on like so. Height. And still get the balance. So 1, 2 in the top, 1, 2 in the bottom, V, 1, 2 in the top, 1, 2 in the bottom. Nice. That makes the calculations quite a bit faster because like it literally does have to do like digit by digit multiplication where the digits are 64-bit integers. Karatsuba. Actually, Karatsuba is not. It's not Japanese. It's Russian, right? Yes. Good. Okay, that is simplified and will run a little bit faster. Yay. Good job. So the algorithm isn't actually finished being ported yet. In Quake, bhop was with strafing. It's a little bit different, but yes, with strafing. Quake, bhop. It's kind of like half sideways. Power bunny hopping. Quake power bunny hopping. So you're kind of like going sideways instead of forwards. The audio is not routed to the stream. That's what it sounds like when you jump. Oh, they are doing forwards. I remember seeing sort of half sideways. I can show you that. So show keys. Oops. So now you can see like what keys I'm pressing and like whether I'm moving my mouse to the left or right. So normal bhop is like this, and you press A when you're turning to the left, press D when you're turning to the right, but it is just a vector projection. So you can do it. It doesn't matter what direction you're going. You can use different controls. So like I can go sideways, and I can strafe like this, and it still works. I can also strafe backwards, and the effect still works. So also I can go half sideways, and I can like strafe halfway. I'm not very good at it. And surf. Yeah, I'm not very good at it. But like half sideways. That's what this guy is doing. You can see the S key is disabled and not allowed to be used. And you can see that the strategy is to like quickly reach the like gain angle where you are actively changing your current velocity and increasing your speed. Like that's the bug, right? The physics bug where if you are okay, so you can see my speed in the bottom left. It does a vector projection onto a offset plane, and the offset is controlled by which key you're pressing. So imagine a plane that goes like this, and then when I press D, the plane is now projecting my velocity slightly to the right by 2.7 units. And same for the left, it just projects it there. And then it also works like this, and like I can go backwards as well. And of course, like half sideways is like that. So like when you're strafing left and right, it's like projecting your velocity, and then like every game tick, it's re-projecting it onto that plane, and that forms a triangle that's longer than your velocity used to be, right? So your velocity was like straight out forward, but then you projected it onto an offset plane. So now the hypotenuse is longer than your old velocity, so you gain speed. And that's how it works. You can see my speed gaining in the bottom left as it's re-projecting every single frame. Just projecting onto the offset plane. So like when I'm going forward and I press D, I move slightly to the left. And I press A, I move slightly to the right. I said the wrong keys, but you don't go quite straight when you're bhopping. It's a very interesting bug in the physics system. Oi. I already have a good time on this map. Okay, the algorithm. Actually doing work. See how it's all commented out and unimplemented? Oh, my back. A. Simplex. Okay, we have A. Direction. That's 0. I can literally do this. So we need this and we need direction. So this is unexact, unintersecting. I'm going to rename this to escape. So direction, on escape. We're doing on exact direction. Oh no. One argument, not true. 2 arguments, PV3. Direction. I think it's still needed, right? Dist is from here. So topology won't exactly be a just a simplex. It'll also have this direction. Should I pre-construct it? I don't know. Okay, so A is known to be simplex 1, right? Right? What's going on in here? On escape. That's this second thing. But in the first one, we've already pushed it onto the simplex. So it is this one. Next point, is that A? Minus A. Yeah, so minus A, this is simplex 1. A. That's this calculation. Okay. Okay, what's going on in here? A dot norm. Okay. Okay, so that's going to be this. Is A guaranteed to exist? We start like this. Yes. Okay, we start with a simplex with 1 vertex, and then we push a vertex onto the simplex. It is guaranteed to have 2. This might reduce it to 1, but then we push another one on. So okay, so 1 is guaranteed. Okay. Good? Question mark. So then I think I should just directly construct topology, and topology should include the direction. It maybe topology isn't the best word. It's like incomplete. An intermediate data structure containing a partially complete calculation. Like if you don't care what the actual distance is between your two meshes, you just care whether they're or not they're intersecting, then like you don't have to complete this calculation because it's actually kind of a lot of work to calculate. So I should definitely skip calculating it if I don't need it. Jones Girls. How big is this? 36. Really? There's size. That's 8 bytes. And then 4. Four times. Is it 8? 4 times 8? I'm confusing myself. How big is a Minkowski vert? Nobody knows. 8. Oh, those are U32s. Okay. Okay, so it's 4 times 8. $32 plus 4. Wait. Plus 4. 36. Align 4. They're using a U32 for a Ravec length? The current len uint. They're using a U32. I did not expect that. Interesting. Weird. I didn't expect that. Okay. Yar direction. So that will change the alignment of the struct, which is okay. It's not a big deal. Okay, let me try this. Mesh vert simplex 1 dot norm direction is negative, and that does it. That's it. There's your calculation. That's all you got to do. To test if it contains the point. But to test if, or to get the actual like topological location on the mesh, which is closest, which is the point of calling this topology, it's going to be more work. Arg. Okay, well, that's fantastic. Does that actually work? Can I actually use this and like test it and look at it? Is there a code path which will fail? Minimum difference. I might actually be able to use this here. Reduce simplex. What? What? All right. Rename variable. Yeah. Stage. Ah, jeez. Okay. Contains point. All right. So it compiles. Can I use it? Why don't I smack it onto the Minkowski mesh and try it? Okay, look at that. Is point in mesh. So I can actually rename this function. Yoink. Yep. And then instead of doing all this crap, I do create contains point. Yes, self. Yeah. Oh my god. What in the... Oh, wow. Okay, well, that's nice. Okay. So now a bunch of code got activated. Yeah. Okay. Oh, that's not implemented. Do I need that? No, it's unused. It's unused. Okay. All right. Let's watch the game crash. Let's go. It's been a bit. It's gonna crash. He's gonna crash. It's gonna like divide by zero, infinite loop, or I don't know. Probably those are the only. That's what I expect is one of those two. I have no idea what's going to happen. Okay, so were you making a game on Roblox in 2023 like b-hopping? Let me answer your question. Why is it running? Let's see. I gotta like. I gotta like say something when it's running. Is it working? I don't know. All right. man. It runs once. Fantastic. And is broken. Let's go. So it doesn't say run start. Watch. So there's an invisible zone here. Oh, I should probably do this. So there's an invisible zone. That's the start zone. I walk into the start zone. It should not have said starting a new run there. I walk out of the... Oh, I see. So so this is like creating new run. I should probably change that text. Okay, so contains... I'm going to go here and print it. Let whatever equals this, and then I'll just do this, honestly, like whatever. Okay. So now I can actually see the result of the calculation. Go, build it quickly. False. So it does not think that I am intersecting with the mesh, which I very much am. False. Not good. Not good. I must say, not good. It's only that is only really used to check to see if you're inside a zone. So it's not, but it's clearly not entering an infinite loop, which is good. I'm not sure if the time is right to debug the algorithm. True, false. Oh, I could just jump here. Interesting. What to do? I can't believe the code is running. And it didn't, like, break instantly. It's clearly wrong in some way. But I expected that. It's gonna be more work to run the other stuff. Closest fev. Yeah, it's gonna replace this. That's the intention, at least. So yeah, it'll be like this, and then that. Why don't I just question mark this? It's a freaking optional. Yeah. My calculations are wrong. crazy. What's this? Contains point. Oh, recalculate touching. Okay, there we go. Uh, is that negative? I think it's positive. So, like, imagine, if you will, a Minkowski sum of two meshes, and it's like moving the second mesh as far as it can in the direction of the test point. We're trying to find if the mesh contains the point. So it's going like, and it's going as far as it can towards the test point. And like once it is contained, so like it's the same as placing the mesh on the point. The distance from the Minkowski sum to the point is the same as the different distance from this mesh to this mesh if you place the mesh on the point. It's the same. It's the exact same calculation, just like... No, it's not the same calculation. It's not this. It's the same result. It's an equivalent calculation. It's a very convenient equivalence. Yar. Why don't I just like go ham, start printing? Like, go for it, man. I expect it's going to print fast fail. That's my expectation. Fast fail. Exact. Really? Uh-oh. Negative is greater than... Oh, no, that is the same thing. Oh. Wait. I got this backwards. Negative is less than. 0. So if the negative value is less than 0, then it is positive. Whoops. So potentially it's gonna work, but not on the first go, unfortunately. All right, fast, fail, false. Then R contains point false. Oh. I literally flipped it. Is it 0? Wart. A dot norm. This is A. Norm is direction unit, but we don't care about unitizing the vector because we're not comparing to radiuses, we're comparing to 0. Did you fix your sleep schedule? I went on a vacation. I'm on a European sleep schedule. I do plan to keep it this way. I want to keep waking up at 6 a.m. Okay, so this was wrong, but it's still returning something I don't like. Dist equals this. Dist is positive. Print that sucker. Dist. Cool. Where did you go? Oh, you didn't know. Spain. And Portugal. Do recommend. Okay. Fast fail. Dist is exactly 0. This is all of the digits in hexadecimal. What? Contains point. Is one of these 0? Is direction 0? Print it. Pay for the plane ticket. It was actually my parents who took me on the trip as like a 30th birthday present. Very nice. Thank you. Okay, what does this calculation say? Direction, okay, it is 0. The direction is 0. Okay, on exact. What about here? What is the initial direction? Hint point. Fart. Yeah, I guess I should do it here. It doesn't start out as a tetrahedron. Okay. All right, just go for it, man. Ugh. Awesome birthday gift. I was against it at first. I just wanted to do this. Just sit in my house and write code. Okay, direction. Look at this. It's hex. Okay, so the direction is 0. Huh? Is this a degenerate case? I think this is a degenerate case. Because literally what I'm doing is I'm teleporting you to the center of the start zone. So that is no direction whatsoever. So it cannot fast fail. So then dot is positive. So this is 0. Not is positive. Not is positive. So this is 0, which means this, it is 0. So then it does this because it's 0. Exact closest point. Huh? Ow, 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 ow. Okay, what about... Find a sign of ever no. Oh. All right, what happens in this other guy? Wow, wow, wow. So if the relative, okay, if the initial axis. Okay, so this is 0. Initial axis is 0. This is interesting. It looks like a failure case. Okay, so if the test point is the hit point, or the hint point is guaranteed to be inside the mesh. So it'd be easy to just add a case and go like, oh yeah, it was inside the mesh. Like right there. But that slows down every single calculation that's not that one single degenerate case. So what does the query what do the query functions do? Geometry query cylinder if not dir max dir yz greater than 0 pull abs max equals 0 return pull. Okay, so it returns like a point on the surface for that one. What is this guy doing? Fartvert. Iter enumerate dot max. So this is just going to return whichever one is first. It's going to return 2 random vertices. Oh, I gotta write it down. I gotta write it down. Direction is 0 because we are teleporting directly to the center of the mesh. Oh. So this is just like a guess. So maybe I'd literally just do this. And I go like, if direction equals 0, just choose any direction. Degenerate case. It cannot be 0. It just cannot be 0. So maybe it'll work. Maybe it'll work now. Guys, maybe it'll work now. Guys, maybe the algorithm is going to actually run and break. Okay, fast fail. R. Fast fail. Contains point false. That's not looking very correct, but All right, so direction was 0. Oops. God, that's so irritating. Fix wrong. Fix degenerate case. Good. Very good. Good, it doesn't work. It's better than not existing. Fast fail. We keep fast failing. Direction dot next. Wait a minute. Oh no, this is a minus. Wait a minute. This is a dot norm. I think I actually need to subtract off the point, because this is which is defined in the code. Relative simplex as the difference between the two meshes. But I'm not hitting this. So A is by itself. Hint point plus rel pause. Is it A plus rel pause? So rel pause is B minus A. Well, not these B's and A's. Minkowski mesh, it's mesh 1 minus mesh 0. Rel pause, it's a point on mesh 1 minus a point on mesh 0 is rel pause. So this is also mesh 1 minus mesh 0. So that's a plus, right? If we want to we want plus, and that's the same for the G, right? So like it should be plus. I think so. Because it's A minus B. It's just A minus B. Mesh 1 minus mesh 0. And point is also mesh 1 minus mesh 0. So these have the same like parity. So it's plus. And we're not doing like subtraction in the calculations. It's a lot to think about. For direction equals reduced simplex hoobity doobity equals 0 p minus p0 is a1 minus a0. Do all of these calculations need the rel pause? I think they do. Because this is b minus, this is mesh 1 minus mesh 0. So like even though sometimes I subtract them, sometimes I don't. Shrimplex. Okay, so we need the point. Okay. So I think that every single one of these needs a plus point. And that is now more correct, Amundo. Simplex mesh rel point. Should I just change the variable name? Point. Minimum difference to point. I actually like that a lot. Sick. All right. All right. Does that fix all my numbers? Doubt. This is very complicated. There's probably multiple bugs going on. Fast fail false. R contains point false. So anytime I have mesh.vert and there isn't a difference between two mesh verts, that needs the pointy point guy as well. Like so. Enable fast fail. Fast fail is failing really fast. Let me just read that code. It says false. False. Yeah, let's look at all of them. Yes, yes. Oops. Okay, but it's always diffs, so we're chilling. XD. What? What is this? We'll see. If we need it. Okay, next. Good. Uh, you know what? What if I just did it right here? Because that's like the only place it's used, right? What if I just said like P0 plus GABA? Yeah, because it's the only one. It's the only one. Everything else is diffing. Big diff. Diff, not diff. Diff, not diff. So, it's less work, and that's like quite a bit of the point of this algorithm is to do less work than other algorithms. So if I just it's not that much work. It's actually almost free compared to the rest of the calculations, but every little bit counts, right? What? Um, we're failing too fast. It's a fast fail. Is it Rayvac copy? Repper C. Oh, apparently it's in freaking nothing. It's not copy. Hmm. What if I disable fast fail? What happens? Does it like get the correct answer? I would expect not. I would expect it's like just totally wrong all the time. All wrong all the time. Wrong. Wrong. Yep. So it's not because of fast fail. It's just wrong. So it looks like there's one loop. It goes like, and it's like, and it just fast fails. How does it fast fail? Dot negative direction. Oh. Fart vert direction. I got no idea. A direction less than or equal to 0. That means it's not positive. Zero to one. Or I guess we don't need abs. We just say that. The determinant doesn't rely on the distance. Couldn't there be an offset that makes pair. It's crazy. tough. It's so tough. I don't know what's firing. I gotta print it. What theme is that? This is a Sublime Mariana theme. All right. Show me which condition is firing. Procking the if statement. Contains. So I did a fast fail, and I did another fast fail. So I gotta disable the fast fail and then like look at it. I don't remember. Looks blue. Oi, oi, oi. Both are true. Wait. Did I collect two of the same vertex? Equals. Really? There's no eq? Minkowski vert. Trolling. Oh, this one has it. Probably we want to know. I hate crumbs. Are we just finding the same point? Is that what's going on? Okay. Wait. Am I stupid? Am I stupid? Am I stupid? Hold on. All right, this says PQ. I am stupid. Ah! Okay. Okay. Let's try this one again. Okay. Howdy doody. Okay, we got true false at least. True false false. Cond 1. So we didn't get a whoopsie anymore. Yeah, that was a big whoopsie. So look, Q minus P. So P plus Q minus, wait, this is also backwards. Q minus P is 1 minus 0. Positive. 1 minus 0, 1 minus 0. So it's using the direction positively, which is correct. And then, so P negative on that direction. Let me look again. Direction. Okay. So, so it's doing a reduction. And I did not do that. Ha! Okay. Okay. Found a bug. There's a bug. I found a bug. So we know it's going to be this ace. But we don't really care at this point. So first and foremost, just smash it. Please smash it. This is so sad. So potentially this is why the algorithm was not working at all. This as well. False. R? False. Ah! We do have a new direction, though. So it's not just a smashing direction. It is a directed direction that goes in a direction. It's true. Can't, no. One always stays one. It never goes to 0. Yeah. I am loving the hex print. Absolutely loving it. True, false. Did I get opposites from last time? True, false. True, false. No. So what is cond 1? Direction dot. Next point minus A. So next point was just pushed to the front. So it is number is 0. And A is number 1. This is the simplex. So we're doing minus A, and that's minus A. Zoink, like that. It just looks right. It looks right. Do I still have fast fail disabled? What if I don't do that? Does it still wrong? Probably. Everything looks wrong. It's all wrong. Fast fail. Fast fail. It's all wrong. When a negative number is greater than 0, when a negated number is greater than 0, it must be negative. Oh, it's not working. Fart. P fart. Wait. PQ. P is negative. Wait. PQ. What did you ask Santa for Christmas? That is not a coherent sentence. I'm sorry. You might try improving your grammar before asking me about what I asked Santa for Christmas. For. What did you ask Santa for Christmas? Now there's a sentence I can respond to. A 4K 10-bit HDR 240 hertz monitor, and it's right in front of me, and I got it before Christmas, and I am Santa. Thanks. Let's go. Yeah. I'm living the dream. Mega high refresh rate. It always bothered me that my stream is recorded at 120 FPS, but my monitor is 165, and that's like not an integer multiple. So now you see every other frame that I see. Assuming Twitch can display 120 FPS in 720p. Okay, so 0 is positive dir. Is this actually correct? It's 1 minus 0. Am I stupid? Positive dir. Okay, let's do it. This is mesh 0. This is mesh 1. Yoink. So we want to find the farthest vertex in that direction. Mesh 1 minus mesh 0. I think this is correct. So we're going positive direction for mesh 0 and negative direction for mesh 1. I think that makes sense. Okay. Yar. So that means positive 0 when you put positive in fart vert. Yeah. So P is mesh 0, Q is mesh 1, positive, positive. P is mesh 0, Q is mesh 1, negative, positive. Okay, I think that this is correct-ish. Why you no work? I'm just kind of like recalculating these points like it's nothing. It is a rather fast calculation within the physics, but there is probably a way to like cache a little bit and like reuse this calculation. Excuse me. Man, I can't wait until I can have like a bit level const-generic where when I add two numbers, I can widen it. That would be great. It's the max of 2 plus 1. I don't know why it's not working. I thought I was diligently implementing the algorithm, but clearly I messed something up. And I don't think it's even in the weeds. Like I run this code and that's about it. Oh yeah, there's this thing to do. I have to be careful about this. Why did that do that? All right, I'm gonna be safe. Okay. I'm just gonna stay safe. I am not supposed to show this on screen. That's right. Let's see. Oh. Alright, that's a little bit nicer. Um, okay. Okay. Close. It's gone. It's gone. It's gone. It's gone. So I had to do some secret technique. Okay. Uh, I don't know what's wrong. Okay, what about the 1, 2, 3? Let me look at the 1, 2, 3. So if D0, then reduce 3. But there's 4 components. So, yeah. So it's doing reduce 3, even though there's 4 components. Yeah. Yar, gar, gar, gar. It's not even going into the hard parts. It just doesn't work in the first place. And I don't understand it enough to debug why. So it is failing fast. One, that's Q minus P. 1 minus 0. It makes sense. So it's doing cond 1 is true. But direction is no longer 0. The simplices are not the same one. Hmm. The type algebra here can go pretty hard, I think. I can remove a lot of cases because, like, right here, I know for sure that the simplex has one object in it. For sure, for sure, for sure. And then right here, I check if it has 4. And then after this, I know for sure it does not have 4. So it's 1 to 3. And then here, I add 1 in, so that becomes 2 to 4. And then, so I don't need to handle cases 0 and 1. And like, this is guaranteed to exist, right? 0 and 1. Right? Makes sense. I wonder if it can do that code, compile it out to the same, and like see through the whole thing. So, okay, I have this written at the top. What if simplex was an enum? But what if you want to index it? You want to get the first vertex. Well, now you have to have a match for both. You can't just like go to the memory location and get the first element. Type situation. Yeah, I feel like it would make an if statement and then have the same code in both branches. But I don't know if it would be able to simplify it. Um, I don't think it'll help in the problem I'm having where I don't know what's going on. I don't know why the algorithm is failing. It never does this. It doesn't get here. It prints this once and then fast fails. And if I disable fast fail, it's like, oh, cond1 is true, exact collision, which potentially is correct at that point. Is this wrong? Direction.unit? Let me look at the old code. Okay, so it's not modified. A dot norm. That's this. This is A. Norm is just direction, but not unitized. And I don't actually care about these values. This is 0. So if negative dist is less than 0, that means dist is greater than 0, which means dist is positive. So that looks correct. Unfortunately, I can't narrow down the bug. And it's never hit this. I wonder if I just kind of keep going and like ignore it and work towards the fev. And that'll exercise the code better. It kind of sucks. I can't compare. I'm pooped. It's just not running anything yet, and it's not working. Does is positive return true for 0, or is it strict? It is strict. It has to be, because I relentlessly use this. Specifically for that purpose. To like replace inequalities, because it's better. It's because it's harder to write with the fixed point arithmetic. Like it ends up as this, and I can write this where this is greater than fixed 0, but now I've got this big chunky thing here. I don't know. It's like constructing a big object just to compare it, but I can just check the sign of the number, which is faster. Am I doing that? Surely I'm doing that, right? Oh, God. It's kind of crazy. Yeah, strict. So I don't know what's wrong at this point, but it is a degenerate case. So like that's kind of what I mean to exercise the code better. What if I change the direction? Because like there's this function, choose any direction. But I'm just like, why? What happens? I don't know. Fast fail false R fast fail false. So it looks like that's the same numbers. So this is the old one, 1229 6CF 1AF. Oh, 61. Okay, so it is slightly different. C8B. So this number is different, but it didn't really change anything. I'm just wondering if it'll change the outcome. Ideally it's robust. False, false. Okay, so it didn't change the outcome. So now this number is different, but it did not change the outcome. So, okay. Is this okay? Not is positive, which means less than or equal to 0. I don't know. I don't know what's wrong. This is so sad. I don't feel like I'll find anything by making the enum simplex. I think it's worth it to try. But I also need the rest of the algorithm. This part right here is like not done and not used. Ay, 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 ay. Shrimplex. Unexact. So simplex is Trey's version of Fev, actually. Okay. Interesting. And it's all defined by the vertices. I see the abstraction. I'm not sure if that's a good abstraction or not. Just topology. So I'm most interested in topology. Face ID. Yeah, it's good to enumerate the faces, edges, and vertices separately, I think. Haha. You could use a cyclic redundancy check or something to not care about the vertex order. Uh, wouldn't work. It would have collisions though. That's for comparing two faces using only their vertices. So that's what all the hash stuff is about. That's because he doesn't have the actual like face ID. So he has to check if two faces are the same face using only the vertex positions. And that's why that's such a huge algorithm. It's cool that I got this to a point where I can run it. It's not cool that it doesn't work. What to do, what to do. So something I could try to do is change from simplex to fev. And then when I am doing this push thing, I think that would be too hard. The algorithm is like deeply cooked for simplex. Oh, I really did a lot of debug work today. Merci. So doing negative point wouldn't make any difference. Well, why don't I just do it and then it's wrong, but it'll exercise a bit more code. Where'd it go? Oh, there it is. So just do negative point and just what happens. I think it's wrong. Oops. Oops. Not good. It is exercising more code, but the code is breaking. I don't really know how it's supposed to protect against that. It's a crazy algorithm. Maybe I should just like convert it to the new one. Trey wanted me to wait though. It's tough. Oops. Haha, contains point, false, fast fail. I will put it back, run it again. So like triggers are still activating and stuff. Fast fail. Oh, hit a trigger. Oh, okay. So it's not running the code because there is nothing in the region. Okay. But there are other things that you do actually spawn intersecting with something. Here? No. Right. So it's like this thing. Yeah. So if I trigger here, yeah, so see how it's running the calculation and failing every time. And then same with this. It just fails every time. It takes the fast path out. It's like, I'm done the algorithm. I just don't really know if it's right or wrong. It's probably right in most cases, but I don't really I don't think it's ever returned a correct value. So, whoops, yeah. So my old test was like extremely ad hoc. I just threw together 2 sweeps. Might be faster for bhop actually if I did it like that, but not for strafe client. The sweeps are expensive with the Minkowski sum. Does this thing have the fast fail? So it's never not fast failed, which like might be correct behavior. I don't really have a way of knowing. Should I try to make a Lua VM and like run both code? Arg. I think that's an idea. Would take a little bit to do. Shouldn't be that hard though. It's like really standalone. Trey is so good at that. Yeah, it has 0 dependencies. Call. Don't really want to do that. It just I didn't do it for the push solve, but the push solve kind of just started working after I was shaking it, shaking out the bugs. Just hoping for the same thing with this algorithm. I'm not sure. So there's multiple paths I could take here. I could try the simplex enum idea and see if anything falls out of that. I could. Oh, did I drink this? I did not. As cold once again. I heated it up and then let it cool down. Or I could use Trey's new code as a reference. But I'm not sure how different it'll be. Trait. I could do dynamic dispatch. That's outrageous. Wouldn't really make the matching nice. I'm most interested in the enum, I think. I'm just gonna try that and see what happens. All right, so simplex is not real. So we are going to have 1 to 3 and 2 to 4, I do believe. And maybe that's it. Oops. XD. So simplex 2 to 4, you can have 2 verts, 3 verts, or 4 verts. Simplex 1 to 3, you can have 1, 2, or 3 verts. Shrimple. Shrimple. Show shrimple. So then det is 0 is always on a 2 to 4. So we just go like this. And it removes a bunch of cases that are unreachable. And we go like shrelf. Yep. And then instead of as slice, we just match self. And then that's it. 4. Do like this. Oops. Is that allowed? Yeah, okay. So then same deal. 4, 3, 2. Just like that. And that's it. So now there's known 3 cases, no extra goofy goobers going on. So then reduce simplex, I do believe, is also on this. So you always reduce 2 to 4 into a 1 to 3. Oh wait. But I think that actually this is a result. So the result is either a simplex 1 to 3, it has been reduced, or you're done. You've found the calculation. And I don't know. Do you actually need that here? Number 4 on escape equals on escape. I guess I can just deal with it. Okay. There it is. Okay. On escape, simplex, refined to exact. Okay, so it actually is using A, B, C, D. Okay, it's guaranteed to be a 4. So this is I can actually name this up here. I can say type simplex equals this const n usize and semicolon let's go. And then this simplex 3 do like this. Yes, sir. And then now I can use this to my advantage. I don't appreciate that. I don't like the tabbing here. All right. So result, either the collision is a success and we get a simplex 4, or we have to do more calculations and it has been reduced. So this is not real. Just totally not real. 2 to 4. Oh, interesting. So actually reduce 1 is this code. Simplex 1 return simplex 1 with direction. Oh, we need mesh. Goobert. Do we also need point? We do. So this is known at compile time. So then this is only used right here. Interesting. So this actually forces this to go down here by nature of type safety. Fascinating. Okay. So this is not real. New point. So are you allowed to do that? Holy. So then reduce 1 makes a simplex 1 to 3. So I'm going to say simplex 1 to 3, 1. Can you see the type safety coming in? This is going away. So this is going to be simplex 2 to 4, 2, boing, boing, comma, yarg. Like this. You good? Result. Okay, this is an error. Oh, it's goobed. I goobed it. Okay, we'll go with V. And then here, V. Okay. Oh, I forgot a semicolon. So this is not real. It literally is not real. Literally. Okay, so we do simplex 1 to 3, 1. Error. A little bit goobed. 1. V1 is gone. Always. Yeah. It either you're done or it shrank. You're done. All right, I'm just gonna like take a look see. Fn on exact simplex. This is a 2 to 4. And this is exactly 4. Fascinatingly. This is very interesting. So this is where I push into this shrimplex. So we can go do that at the top. We can say impl 1 3 push front self 2 to 4. Always it adds 1. V Minkowski vert. Yes, sir. So then we match self. Fill them up, fill them up. So if you started out with 1, what's 1 plus 1? What's 1 plus 1? It's going to be 2. So S2, 4. Zoinky, boinky, doinky. And then this one, V0, V1, V2. So this starts with V, and then we add in, yay, we add in the rest. And that should be correct. So all we do right here is let simplex equals simplex dot push front next point. And this has changed the type. And I don't need to call it push front because it literally just does that. Okay, so then this indexing is a little bit freaky. So we already calculated it right here. Um, so we can go like, that's right. But then we still have to do this. Yar. So now we can say debt is 0. I have to implement this. So do I have to though? Could I like not? So this and this are going to combine together. Watch and learn. So this is going to be a match statement. Sure. Reduce. So I think I'm just gonna make it not a result because like I can actually name them here. What are we looking at? So 3, what's the size of this? I wonder if they're the same size. They're not the same size. The next one will be 32. 36. Isn't that neat? 2 to 4 is 36, just like the, what was it called? ArrayVec. 28, align 04. Align 04. Right. The size of the 20, 28, 36. Fascinating. $36. Cool. What was I doing? Right. Watch and learn. Yeah, I'm gonna make it not a result. It's gonna just be reduce result. So yeah. 28. Align 04. So it will be padded, or I guess it might be folded. Why isn't it know the size of this? Cringe. What do I say? Freaking the inner goob. Okay, whatever. Okay, so then the result of this is reduce. So then this is not an error. This is reduce, reduced. direction with a D, and then simplex with no quotes. Do like this. Ooh, direction. Ah, it's fricked. Show me the money. Oh. Uh, 3. Wow. Wow. Wouldn't you rather it be a tuple? Reduce. Reduced. Direction. Simplex is simply not real. We know. Okay, this is a 3. S1 to 3. 3. Boink. V0, V1, V2. Just like that. With a little scoobert on the doobert. Yes, sir. Whew. I'll just do it like this, because then it matches everything else. Remove. So this is simplified. It now becomes B equals C, which means V1 equals V2. And we need a mutt. Insane. Reduce. Reduced. Direction. Simplex. S1 of 3. 2. Freaking V0, V1 like that. Comma. Like that. I do believe that is the way. And then this is not real. UV narrow unwrap. I'll steal from there. And this is 1. Like that. And then this one is close, but it's just direction. Like that. We don't need this because it's already like that. Woo! Okay. Now for the goobert on the scoobert. The big case where it has all the crazy stuff. 4. V3. Okay. Yes, that's right. Okay. So this is the case where we don't care about the direction. This is the crazy case. Crazy. So it goes like Reduce exact. V0, V1, V2, V3. Exactly this. There's no direction involved. This is a positive detection of what? I don't know. Okay, and then so mutt, I do believe. And this one never changes, which is interesting. B equals C, C equals D. So it's like, hi, V1, V2 equals V2, V3. Do like this. And then this is remove 2. So this is V2 equals V3. I might want to comment that because the stuff is cool. So this is like extremely obvious here. It's gonna look extremely obvious. Actually, no, it won't. So this is V1 V2 equals V3 V1 to C equals 1. Yeah. Cool. Yar. Okay, I say reduce. Reduced. Help. Direction. Colon. This is a number 3. Why is it doing that? Huh? 1 to 3, number 3, V0, V1, V2. Shrimple. Oops. Semicolon. Yep. And then remove 1, remove 2. So this is B equals C. So V1 equals V2. Remove 2, nothing happens. I can actually remove this. Oh. It was totally removed from the calculations. Do it again. Two? Yeah. Neat-o burrito. Okay, and then this is also 2. Ah. Okay, if statement. Okay. Okay, there's no such thing as remove. UV, negative UV, and then this is 1, like that. Real. You good? Okay, so then this unreachable pattern. Really? This is an unreachable pattern, you say? Oh, well, I've already annotated as such. And that's the point. That's why I thought the enum would be good. Okay, I don't actually know what this is going to do. Unexact. So we actually have one here. So we want it there as well. Push front. Oh, look, I was in the middle of this. Fill those match arms. Yeah, that's right. Oops. So when there's an exact, I guess I'll rename that to escape. It does this. And there's no case here. It just immediately does that. So this is wide, and this is narrow. So I'm gonna call this something not cringe. Expanded. Big, whatever. It doesn't matter for now. And then now I can write simplex equals simplex. So I'll call this one small or something. Small becomes big, and then small is replaced right there. Cinema. Direction also needs to be replaced. Variable names. Dir. It's only the last one, interestingly. Simplex 2-4. So, see ya. And we're good. Okay. So it did actually make an alternating type thing where like it reduces the number of it's more strict. You can prove that it won't be a certain length. I gotta keep going. What the hell is this? What the hell is this? So this is a 2-4. So we gotta make this possible. Okay. So does that mean I need it only on 2-4? I don't know her. All right, 2-4, 1-3. I'll just smash this right here and pull S24. Hey, where would okay? No, it's index something for something. T index T for we need can you have 4 const n? Can I do where 4 const n use size? Minkowski vert and implements index T. Hell, probably not. Const generics, only lifetime parameters. Okay. What about like this? Okay. Not all trait. Okay, shut up. D. Oh, output equals as index output. Stop typing DN. Okay, so then we got the T, we got the output, and we go match self. Yes, sir. And then we go like hi. And then we go like array. Whatever. And then S index. Slice. We want. Do I really have to copy the whole thing? just to get one of them? Ah! What does this say? So yeah, it's saying, oh yeah, just do slice index. That's not what I'm talking about here. Okay. What if we go like this? N, true. 2. Output equals. Oh god. Oh, we actually know what the output is. Haha. How's your day been going? Expected reference. What? Oh, wait. Wait, real? Yeah, saying slice index. I do not want that. As index t output. Boy. Alright, I give up. No generics. Unlucky. Feels bad. Index usize. So yeah. Reference. Yar. Okay, something, something, something. Okay, what's going on down here? First assignment of direction. Oh. Cannot assign twice. Immutable. Oh, it was immutable. Oh. Wait. 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 But it only did one loop, so it doesn't matter. The old code said direction equals. Okay, but it did this. Okay. Thank you, Rust. Okay. Okay, so now we have index. Woo woo, index. I hope it can like const. Get out of there. I should use, what is it called? Godbolt. Okay, what's going on here? Refine to exact. Generic. Refine to exact. What you doing? 4. Okay, bub. 4. Refine to exact. So this is like something. The ball was this 2 to 4. So I don't really know what's going on here. What if I just say this? One, I don't know, whatever. Okay. So then, two, whatever. We do not care. Okay, so now, there it is. Refactor using simplex enum. Holy moly. Oh my god, that's a lot more code. So yeah, so now all three of these cases are gone. They don't matter. They're all unreachable because we know for sure that it's the list length is 2 to 4. Let's see what happens. What's going to happen? I doubt it'll work. False. False. Unlucky. Doesn't just work. Okay, so, oh, that's why there's so much code, is because all these are huge. Yeah. It's pretty cool. I can now use this exact function instead of the general function. Cool. That's cool. So this is like for sure. Right. I'm trying to think of how to test that this compiles good. It's not that crazy. Really cool. Structs and enums. I could totally do this in the push solve algorithm as well. So like in this one, we know that there is a single point here, right? So we're getting this contacts list. So then we push one on, and then like we get something back. And something, probably similar. Where it could be an enum instead of an array back. Okay, so as expected, the algorithm fails in the same way. But it sure was cool to implement it and see the guaranteed lengths in play. I want to write this 2 to 4. Let's do this. God bold. Tell me. I don't actually want to compare. I just want to see it. GCC. Yay. Okay. So this is not real. God damn it. Okay. Index. Moo. Oh, it's still going. Oh, God. Panicking. Okay, so how about pubfun YOLO? Let A equals simplex 2 4 simplex 2 1 2. Let B equals A 1. Is it just gonna be like yellow? Okay, so it's calling this other function. It can't see through the fog. So it's like call. So it's calling this other ginormous function. So it actually can't see what's happening. So it's not like compiling away and it's like, oh, you have an array of length 2, 3, or 4. Well, then getting the second element of that array will never panic. It can't see it. Can't do the bounds checks go away. It's always panic, panic, panic. No! And I don't know how to make it do that. Org. Like, if you knew the layout, you could just go like fetch it. You could just like assume it's an array and fetch it from the array memory address, like read pointer. Because it'll always be there. It's guaranteed. Unlucky. I mean, it'll still work. It's not a big deal that it's unlucky. It's just gonna like do extra work when I do this. This right here. And I'm also doing a same thing right here. And that's the only place I need it. Like the previous next pause is always this, right? So could I just do last previous next pause? Hmm. Okay. Very nice. Very nice. Well done. Well done. Um, I wonder if yeah, no, it probably does simplify things. I could say drop actually. Pop it and drop. So like remove. Instead of remove, I could be like drop. Go like here. So find all the pops and drops. Remove one. Drop. Drop. So like it doesn't actually change anything. Okay. So it's saying like you just like copied it, you goob. What does it say when I compile? Yeah, so it's like um so calls to drop with a value that implements copy does nothing. Unlucky. So I can't like explicitly. I guess I can explicitly. No, I can't. Does that really help? Hmm. Hmm. Is that from the same? Yeah. Copy does nothing. Wouldn't that also do nothing? Because like I could just go like v1, and it's like okay, and it would just be like okay, but I want it to like go no, you're done, you can't use it. But I can't. Just have to be careful. Whoa, it's not mutable. Crazy. Let's go. All right. It was a cool refactor. It's a good idea, except for like the numeric indexing, where you like, oh, I want to get the first value in either the first list, second list, or third list. You can do that, but you need this like freaky deaky index thingy. Is there like a lower level dink I can use? Oh, abstat. Yes, sir. Look at how there's none of that. It doesn't happen. It doesn't happen. Not in my world. Yeah, I mean, that's pretty much it. Ops index in an immutable context is actually syntactic sugar for, but only when used as an immutable value. Yeah. Dref. Wow, that's actually makes it less magical. Hmm. Wait. So it's like cannot be known size deref. Is this slice copy? I'm actually curious now. Y'all got any slices? There's a slice somewhere. Does the like raw unsized slice implement the copy trait? Where are we going? Would I even be able to know? Let's run the AI and ask the AI. We got GDB. Huh. Oops. Okay. I want to go outside and like eat something fake. Not real food. Simplex 0. Oh. Well, no. That's. I can. Hold up. P0. Or, oops, V0. Like that. Well, let's go. Uh-oh. I see. Copy. Yeah. Interesting. I should like surely the index is known because it's a fixed length array. Is that cleaner? I think it is. Should I make reduce to reduce 3? Honestly, I think that'll look nicer. All I need to do is go like joink and boink like this. You're here. Reduce 2, simplex 2, shocker. And then yoink from here. Reduce reduced. I think I'm gonna separate out the struct because like it's gonna be sucky. Did I just exit? No, I didn't exit. All right, zoink it and boink it. So instead of reduce reduced, we do just reduced. And everybody very happy, very happy. Mismatch types, lying. Good. So then watch this. Reduce 2. Oh, fantastical. Next. Three. Yar. Mayhaps it is better. Ooh. This game is easy. 3. Yeah. Okay. And then this one actually has some Scooberts in its Dubert. Oh, I goofed. Four. I believe both of these are like that. True. GG. Okay. So then instead of do like this, we do like this. 4. That's not a 4. 4. And that's amazing. Four, 3, 2, bow. Yeah. God. All right, I think that looks cool. Cool. So now I can like not have it be insane as well. Yeah, that's better. Yeah, I'll keep it with those variable names. Yeah, I like the like tab in of separating the functions. What happened here? Really? Really? What? Yeah. Just get rid of it. And then there's 3 little guys, 3 little cases here. Just totally known. Cool. Split, reduce. Maybe I'll even member function it. Cause like, why not? Bow. Isn't that cool? Self. You here? Maybe I'll go like this as well. And then self. And self, because why not? And then change this. Big, reduce. Make small. Insanity. Split, reduce. Reduce member function. Yep. GG. Very cool. Very, 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 very cool. Wow. It's cool. Reduce one. Uh-oh. Actually, literally, this is reduced. And I've actually cooked here. I've actually cooked. I did not realize. Okay. Well, now I have to rename the freaks. Is that how you do it? It's kind of weird. Like, I expect it to deconstruct, but it's just kind of... Yeah. So now it actually has the same signature as the other ones. It's cooked. Fully cooked. Rather, I guess I am cooking. You can... What's this saying? You're either doing the cooking or you're in the pot. I'm doing the cooking. I like it. I think the function separation with a low tab depth is nice. We haven't even run the like complicated parts of the code. It's just like failing on the basic algorithm and the like simple checks that it starts with. Yarg. I'm gonna double check all of these. All right. Okay. Oh dear. Did I untab super hard here? Okay, so this is obviously simplex 1. Okay, there we go. So we have v0, v1. And then that's where it pops. So now we only have 1. So it starts with 2, pop, right here, only 1. Okay, next one, there's 3. There it is, 3. Pop, 2, 2, pop, 1, 1. Okay, 4. There's 4. That is the escape condition. And then we know for sure it's 3 now. But then we pop. What is going on here? So this is the escape condition. Right. So we're like, okay, it was like not the good case. So then we go like, and then we go pop, like right there. This thing is right here, kind of. It's right there. So this is the pop. So now there is 3. 3, 3, pop, 2, 2, 2, pop, 1, 1, 1. Okay. Pop, 1, 1. Okay, so from what I can see, that's all correct. The problem is like I can leak things. I can just go 4, 0, 1, 2, 3, and it's like it's a valid return value. Oh well, 3 I guess. Like I can even just like do it totally wrong like this, and it'll be like, oh okay. So that's why I was checking. Oh okay. Use struct. Okay. VV nice. Do I think it's better? I think it's the same. It's like it'll have the same performance. I don't think it'll like be that much better. I really do like the like range. It'd be cool if you could have like a const range, const generic, have like a where clause on the size of an array. Something something. Const range. Then you must construct it with like the minimum. And like then you could have like into with const generics with where clause. Const generics is a crazy good feature. Get out of here. I don't need to. Okay, it doesn't know. That's right. Well, I can see. No, I can't. Well, tomorrow I need to keep working. One thing I can do is set up that Lua VM and just like run it on the side and then compare the results and like print what the Lua thing is doing and print what the Rust thing is doing and go, aha. But not today. This was a good refactor. Plus 80 lines of code. It's more explicit, okay? Most of it is coming from like these. I think it's neat that this can never happen. So it's always this case because of the types we know. Just because it's an enum. Well, that's pretty cool. So we reduce the big simplex and we get a little simplex. Or we get an escape condition. Insane. That's an enum moment. Well, all I really did was shuffle things around. That's why I don't expect the enum refactor to like make it have a different result. It still thinks that you're not touching the start zone. I am inside of the start zone. If I walk out of it and then walk into it, it says starting new run. So this code breaks the game, or breaks timers, I guess, as it is right now, because it's wrong. It's just wrong. It's like, oh, you're not touching the start zone. Yeah, I am. All right, I'm gonna end it there. I'll maybe do the Lua VM thing. Maybe I'll do some work off stream with the secret version of the code. But I'm done for today on stream. I'm gonna go outside and like get a burrito or something. So, goodbye. See you tomorrow.